Hi guys, welcome to this course on NEET 2017, and today we are going to discuss some more physics questions that appeared in NEET 2017. Okay, so today we have question number 21 to 25 lined up for you, and I am Vikas Joshi. So now let us begin. So the first question for the day: a thin prism having refracting angle 10 degree is made of glass of refractive index 1.42. Okay, this prism is combined with another prism of glass of refractive index 1.7. So both the refractive index are given, refractive angle is also given. Next, this combination produces dispersion without deviation. So the key point that it is telling, the important information that we have is this combination produces dispersion without deviation. Without deviation, the refracting angle of the second prism should be. Okay, so if you can find the meaning behind the words, like what it is saying when he says that it produces dispersion without deviation, it means delta 1 is equal to delta 2, because there is no deviation, net deviation is 0, so delta 1 must be equal to delta 2. Now let's see the solution. As I told you that delta 1 should be equal to delta 2 since combination produces dispersion without deviation. So what is the formula for delta A mu minus 1? So for the first medium we will have A1 mu 1 minus 1, and for the second prism we will have A2 into mu 2 minus 1. We are having the value of A mu 1 mu 2. We need to find the value of A2. Put the values, get the answer. So upon putting the values, we will have A2 as 6 degree, which is the first option. Okay, so now let us move on to the next question. What does the next question says? Two blocks A and B of masses 3m and m respectively are connected by a massless and inextensible string. The whole system is suspended by a massless spring as shown in the figure. The magnitude of the acceleration of A and B immediately after the string is cut. The string is cut. So what will be the magnitude? Okay, so now let us look at the solution. So in this problem we are having a spring that is attached with A, that is of mass 3m, and we are having another block of mass m that is attached to block A with a inextensible string. Okay, now let us look at the free body diagram. Okay, what does the free body diagram says? First of all, whenever we'll cut this string, B will have a free fall motion, so automatically the acceleration for B will become equal to g, that is 9.8 meter per second. Okay, per second square. So now let us look at the free body diagram. What all forces are acting upon this too? For B, it is force due to gravitation, that is mg is acting, and because it is hanging down, so a tension force is also acting, this tension force. Again, this is the tension force for A, that is acting downward, and 3 mg because of its weight, this force is also acting downward, and a force F due to the spring, that is also acting towards the end. Okay, so what will happen at the equilibrium, since like before it is cut they are in equilibrium position, so all the balance must counterbalance each other, so T will equal to mg, this T will equal to mg. Now this F will be counterbalanced by T plus 3 mg, because on A only these three forces are working. Okay, so putting the value of T to here, it will become F is equal to 4 mg. Okay, this is one part. Now after cutting, what will happen? This, the tension that was here, the tension due to string will not be there. Only the weight, for the force only that is acting here is the force due to its weight. Okay, that is 3 mg, and F is still acting upward, so F will remain same 4 mg, but this side the forces have changed, so it is alone 3 mg. The tension is removed, so this, the difference will produce the acceleration. So F minus 3 mg will be equal to 3m, that is the mass, into acceleration. Force is equal to mass into acceleration. Okay, so for putting the value of F is equal to 4 mg, will get 4 mg minus 3 mg, that is mg. So m and m get cancelled, so A is equal to g by 3. So this is our solution. Now let us look to the next question. Two cars moving in the opposite direction approach each other with a speed of 22 meter per second and 16 meter per second respectively. The driver of the car blows the horn with the horn having a frequency of 400 hertz. The frequency heard by the driver of the second car is, velocity is given, velocity of sound is given as 340 meter per second. These are the four options given. It is a very simple problem from sounds chapter. Now let us look at the solution. It is the problem from apparent frequency. Okay, so source given, what is the velocity of source, 22 meter per second. Velocity of the object is also given. Since both are approaching, source and object are approaching, the formula for the apparent frequency will become V plus V naught upon V minus Vs. That is for object, that is for source, and F is the actual frequency, that is 400 hertz, that is given. So now V is the velocity of the sound, that is given as 340. So putting the values, I will have 340 plus 16.5 upon 340 minus 22 into 400, that will give us 448 hertz. That is the third option. Okay, now let us look at the next problem. Okay, so this is the classical problem that is given. Okay, there are I will tell you what could be the other option, what could be the other way of solving it. Okay, first way, that that is I'm solving fully, okay, with full solution. Okay, so what is, if theta 1 plus theta 2 be the apparent angles of dip observed in two vertical planes at right angle to each other, then true angle of dip theta is given by, four options are given. So there are two apparent angles of dip are given, theta 1 and theta 2, and they are observed in two vertical plane at right angle to each other. Then we are asking true angle of dip. So now let us look at the solution. Okay, so what is like, if we are taking this as the magnetic meridian. Okay, so if this is other plane with having uh, angle between both the plane as phi, and this angle is having another angle, that is theta dash, this is known as apparent angle of dip, and the formula that we are having is cos phi is equal to tan theta upon tan dash. So what is this? This is magnetic meridian, this one. So it will whatever it will be having, it is called angle of dip, that is true angle of dip. So now applying the same logic here, this is this suppose this is one plane, this is another plane having angle theta 1 and theta 2, and this is the magnetic meridian. Okay, so if this angle is phi, so automatically this angle will become 90 minus phi. Okay, so now we are going to apply this formula here. So cos phi will become, cos phi for this will become tan theta upon tan theta dash. Let the angle of mean meridian be angle of dip be theta. Okay, and for this plane it will become cos 90 minus 5 tan theta upon tan theta by 2. Now if we'll square and add, we'll get 1 upon tan square theta is equal to 1 upon tan square theta 1 plus 1 upon tan square theta 2, which is nothing but cot square theta is equal to cot square theta 1 plus cot square theta 2. Okay, so this is the fourth option. Now the second thing that I was going to tell you that if you have prepared seriously for your examination, you will know that this result is very important from this chapter and you must need to memorize it. Okay, so directly seeing the this formula as an option, you can directly tick only if you have worked seriously for your examination. Okay, so now next question. A beam of light from a source cell is incident normally on a plane mirror fixed at a certain distance x from the source. The beam is reflected back as a spot on the scale placed just above the source I. When the mirror is rotated through a small angle q, the spot of the light is found to move through the distance y on the scale the angle q is given by. These are the four options. Now I will explain you this problem with the help of figure that will be more clear to you. Okay, so what is happening that this is the mirror and this is the source. Okay, this is the source L and this is the mirror. Now what is happening now, if they are put face to, if they are like, if we are having them face to face, then from here the source of light is bouncing back again and making a spot here. But now if this mirror is rotated to an angle by theta, now this same spot that was earlier found here, now it is formed here, and this distance, that deviation, that is y. So what is asking, he is asking us theta, what is the angle theta. And again one more thing to note is the angle that is given is small. Okay, so that is small. Okay, so now if this is theta, this angle will become theta. Now by the laws of reflection, dropping a perpendicular, this will also become theta. Okay, angle of incidence is equal to angle of refraction. Okay, so now what will happen, will say this triangle, this is 90 degree here, so tan 2 theta will become y upon x. Since theta is very small, therefore tan 2 theta can be written equivalent to 2 theta. So 2 theta is equal to y by x, so theta is equal to y upon 2x. That is the fourth option. So that was all from this lesson. Thank you for watching. You can find me here on Unacademy. This is the link. Please do rate, review and share this lesson, because padega India tabhi to badega India. Thank you.